So let's look at a second example that deals with a completely inelastic collision. Let's suppose that we have a bullet of mass 0.01 kilograms that is traveling along a horizontal axis when it collides with and embeds inside a block of mass 0.99 kilograms that is attached to a spring with a spring constant of 200 newtons per meter. Now, if the spring compresses a distance of 0.055 meters and the coefficient of kinetic friction is 0.6, we want to find the velocity of the bullet before our inelastic collision took place. So let's look at our diagram. So we have our object, the bullet, that is traveling towards our block that has a mass of 0.99 kilograms with some unknown velocity. So we want to find this velocity. So let's examine what actually takes place when the bullet collides with our block. So the bullet collides and embeds inside the block. The block gains kinetic energy, and then that kinetic energy is transformed into elastic potential energy that compresses the spring, and also into thermal energy of the block and the ground on which the block is on due to friction. So we want to calculate the velocity of the bullet in 2 steps. So in step number 1, we want to calculate the velocity of the block bullet system before the block actually compresses, before the spring actually compresses and the block moves a distance of 0.055 meters. So this point happens to be also the point right after the collision between the bullet and the block takes place. So knowing that velocity of the bullet block system, we can then use the conservation of momentum, because we have an inelastic collision, to find the velocity of the bullet. So let's begin with step 1. So in step 1, we have the kinetic energy gained by the block and the bullet is completely transformed, is equal to elastic potential energy of the spring and the thermal energy due to friction. So this is mu, our coefficient of kinetic friction, multiplied by the normal force, multiplied by displacement, 0.055 meters. So this is our elastic potential energy that is stored in the spring, where K is the spring constant and change in X is simply 0.055 meters. It's our displacement of the spring. Now, ms is simply the mass of our system, and the system is composed of the block and the bullet. So that's 0.01 plus 0.99. That gives us 1 kilogram. So we want to solve for the velocity of our system, of the bullet block system. So we leave the Vs on the left side and bring everything else to the right side. So we divide this whole side by ms and multiply it by 2 and take the square root to get the following result. Now we plug in our values. We know what K is, it's 200. We know what change in X is, it's 0.55. We know what mu is, it's 0.6. We know what M is simply 1. We know what G is, 9.8. And on the bottom we simply have 1. We take the square root, we plug it into the calculator, and we get a velocity of 1.12 meters per second. So when our bullet collides with the block, at that moment of collision, the block and the bullet system will have a velocity of 1.12 meters per second. So now, knowing this velocity, we can use step 2, the conservation of momentum, to calculate what the velocity of the bullet before our collision is. So here we have our conservation of momentum equation. So this basically states that the sum of the momentum of our two objects, the bullet and the block, before the collision is equal to the sum of the momentum of our system of two objects after our collision takes place. Now notice, before the collision takes place, the block is stationary, so its velocity is 0, so this cancels out. And we're left with simply mass of the bullet times velocity of the bullet, so mBvB, so we simplify this, is equal to mass of the system, ms, multiplied by mass or velocity of our system. So we know what Vs is. We just found it to be 1.12 meters per second. We know that Ms is 1 kilogram. It's the sum of these two objects, 0.01 and 0.99. Now we know what Mb is. It's simply 0.01, the mass of the bullet, and we want to find Vb, the velocity of the bullet. So we rearrange our equation, divide both sides by mb, and we get the following result. So we multiply ms/vs, so 1 kilogram and 1.12 meters per second, and divide that by the mass of the bullet, 0.01 kilograms, and we get a velocity of 112 meters per second. So that means before our completely inelastic collision takes place between the box, our block, and the bullet is traveling with a velocity of 112 meters per second.